we started with the first chapter. The first chapter, we skipped this section, so we'll see this by end of the course, like we'll see this tomorrow. And we started with the describing the architecture of OpenShift. So the OpenShift architecture is completely based on Kubernetes. So we just have seen the Kubernetes architecture. So what is the master node? What are the components will be there on the master node? Then we have seen about the worker node. Then we have seen how the OpenShift differs from the Kubernetes. So we have seen what is the advantage of using the OpenShift over the Kubernetes. Even though Kubernetes is one of the main, or we can say heart of the OpenShift itself, but how OpenShift is offering flexibility over the Kubernetes, we have seen that steps. And then we have seen about the declarative architecture of Kubernetes. Then we have seen about the extensions, then storage class, like that. Then the next chapter we have seen, the next section we have seen about the cluster operators. So what is an operator? So how the operator can be used, and what is in a cluster operator. So we have seen that, and where you can find this operators, in which place you can go and get that operators. So we have seen that in this section. Then we started with this chapter number 2. In the chapter number 2 we have seen the installation methods. So installation method, we have basically two types of installation methods we have seen. Installation itself, we have detailed concept, so we are not saying that at the hands-on level, but just we have understanding what is how the installation process works, and how what are the types, two major types of installations available. One is UPA method, IPA method, or can say full stack automation, or UPA method, user provision infrastructure. So we have seen that two method in the description of installation method. Then we started with the troubleshooting of cluster application. So we have seen how to log in at the cluster, how to create project, how to create application, how to view the cluster status, like using the different commands, how to get the logs of the cluster, how to take a remote shell of the cluster nodes using the OC debug command, how to take a remote shell of the application, so using a OC RSH command. Then we have seen the OC status, OC events command, OC get events. Then we have seen how to use that Scopio tool. So how we can use the Scopio tool, check the remote image, availability of the remote image. So these things we have seen over that in this section. And next we have started with the dynamic storage. So we have different type of storage provisioning. So first we have understood why we need a storage in the first place. Then after understanding the requirement of storage, then we have gone and classified the application depending on the storage requirement, on stateful application and stateless applications. Stateful application requires a storage, so we have gone for configuring that storage for that application. So we have different methods over there. So we have bind mount and we have volume mount. So volume mount is most preferred in the production side. So volume mount, you can do it in two different ways. One is using a static provisioning, another is using a dynamic provision. So in this section we have just seen about the dynamic provision, how you can dynamically provision the storage to the application. So by having a storage class, by creating a storage class, you will point out to the PVC. So you will create the PVC will point out to the storage class, and storage class will be created by the administrator, and the storage class will be pointing out to the provisioner, you can say the provisioner driver, so that this you can interact with the actual physical storage. So with that we completed. I hope you have completed the labs. So there are 2 labs to it, so I hope you have completed these 2 labs in this section, in this chapter. Then so we'll move on to, actually we will be I'll be skipping this, swapping this chapter tomorrow, because this chapter is, third chapter is about configuring authentication and authorization. Since this, the reason for swapping this chapter is, one is there are some concepts which we will be using here. That concepts we have to learn it. Actually the concepts will come after this. So what are the concepts we are going to use here to configure the users? All these things, the concept is going to come after this. So better if you will complete this, then we'll come and do this one, so that you will understand that things. Like for example, we are going to use here secrets. So secret, how to use secret is actually going to come in this section. So in this 4th chapter. So they are dealing about the secret in the 4th chapter. But we'll complete this and then I'll come back to this. I'll be doing this one by tomorrow. Maybe if I have time today, we can do it. Otherwise, we'll do it this chapter tomorrow. So this is technically not an important chapter. Like this is just configuring the users. how to create the users in the OpenShift, and how to assign permission for the users. This is like a product-based thing. Technically, it doesn't have any things. Like we are going to see some procedurally how to assign the roles and how to create users. After creating the users, how to assign the roles. That are the things that we'll be covering this section. I'll swap this to tomorrow, this chapter. So we'll go to the fourth chapter. So fourth chapter is a very important chapter. So here in the fourth chapter, we have two different sections. One is about managing sensitive information with secrets. So this is the chapter. And next is controlling the application permission with security context constraint. So we are going to see something like configuring the application security. So this is the chapter. So you are going to see some security related things, basic things. It's not like very advanced security. This is just about basically how we start with the secure deployment of an application. So what are the options? So this is just two options we have. Apart from that, there are a lot of options where you can securely deploy the application. But security, because the OpenShift itself, we have a different stream. We have a course itself, DO280, where they are going to deal with OpenShift and container security. So that paper you will see more about security related things. But here we are just going to see about the introductory level. So what are the security options available at the OpenShift? So we are going to see two concepts. The first concept is about managing the sensitive information with secrets. The second concept is about something called ACC. So we'll start with the first section. So managing sensitive information with secrets. So the modern application which we are dealing with, there are two types of can say the datas. Like so normally we are going to see about data isolation and management. This is about secret thing. So some datas which is considered sometimes data may be required at the runtime. Maybe that data is considered secure data. Hello. Hello. Sorry, I got a call in between. Yeah, we'll see about the. Actually, in this chapter, we are seeing about the data isolation and management. So the modern application. So we are seeing that the code, the main code and the data. So we have two types of things. The core application, like when you're building an application, you have your application data, or can say the code of that application, and the application data or user data, so which is provisioned to the application, are loosely coupled. So we want to take advantage of that. So the configuration files or configuration informations are not hard coded as a part of the software. In a sense, like for example, you can take a case of where you are building some application. For example, I'm building some application which is based on Java. You can specify your build environment. So you can specify build environment, like what build environment you want to specifically use to build that application. Whether you want to use so we have, with respect to Java, we have many build environments. So like we have Maven, we have Gradle, like that. So what build environment you want to build it? So build that application using which environment you have to build that application. That environment actually provides you the dependencies for that application. If you're using the Maven will provide the dependencies for that application to be built. So we have the choice to do that. So previously, this was not the case. When the older days, like legacy applications, the core application code and the configuration data so are hard coded. So if you want to modify anything, you have to modify the entire source code. So we don't have a choice to that. So you have to rebuild that application, or you can say you have to rebuild that code again to do that. Now in the modern application, we have the choice to provide the configuration data during the runtime. So you can load that configuration data during the runtime of that application. So this is what the modern application is giving flexibility. So the microservice like that of application. So we have the choice to provision the data when the data is actually required. So we no need to hard code the data as a part of the application source code itself. So only you need to provide that data when the data is required. So if the data is not required, so we'll just run that application. The application will be running. So when in a case the application requires the data, so we need to provide the data. So if not, so we can just run that application in a normal way without that data itself. So that will reduce the overhead on the application. That will reduce the overhead on the developers who is developing that application. So they're not concerned with this configuration file. So that this file depends on the user who is using that application. So when the user requires that, he is going to hardcode. He is going to provision that data during the runtime. And so this enables the application to be deployed in different environments without requiring to change the application source code. This is the advantage of that. And this concept. So we are going to see in some way how this is achieved. So what are the ways? So we are containerizing the application. We are dealing with the containerized application, management of containerized application. Here, how this is achieved, how we can achieve this concept. So for achieving that, we have two entities to do that, the data isolation and management in a containerized environment. One is using something called ConfigMap. So using the ConfigMap, you can provide the data during the runtime of that application. This is one way. Another way is secrets. So what is the difference between these two? So when the configuration data or configuration files or the informations are concerned, the information sometimes may be sensitive information, and sometimes it may be a non-sensitive information. So like non-sensitive information in a sense like the configuration details, like you are providing the IP addresses, the server details, like that. So the port numbers. So this are general details. So it is not a sensitive information. And in other case, when we need to require to provide the details like the usernames, passwords, like the private keys, public keys. So this informations are considered to be a sensitive information. So we cannot provision it as like that. So we need a way to provision this information in a different environment. So that informations are considered we can provision that as a secret information. So this is what we are achieving. this config map and secrets. So these are the core Kubernetes concept. So this is not something which is specific to the OpenShift. Even though we are using this extensively in the OpenShift, so that's why we're seeing that through the OpenShift. But these concepts, so config map, if we take this concept itself, that these concepts are core Kubernetes concepts. So if you are studying, if you have studied the Kubernetes, you might have known this, the config map and the secret concepts. So there you will be studying in the Kubernetes. So this is a core Kubernetes concept. We are using this concept. We are using this in the OpenShift extensively. So we are studying in this another security topic of in the OpenShift. So we'll see about the configuration map. So config map is something which the non-confidential data, so you can say non-sensitive data. So we are provisioning to the application when the application is actually requiring that data. So application is normally running. When there is, for example, when there is application needs to communicate to the other application or needs to communicate to the other server, when you provision this data, that it will do that. Otherwise, the application normally runs in the its own way. So when there is a requirement, we can provide that. But config map does not provide the secrecy or encryption to the data. So the whatever you're provisioning as a config map, so that will be plainly available, plainly visible to the user to be see that data. And data, if you want to store some confidential information, you have to go for something called secret rather than using the config map. So we'll see how this configuration map injection happens. So we'll see an example. So we'll take a namespace or project. So remember that namespace and the project are the terminology wise, it's both are same. Like in the Kubernetes, mostly we use the term namespace, and in the OpenShift we use the term project. So but both are synonymously same. So namespace as well as the project both means the same. But in the Kubernetes world, namespace is not, they are not giving much importance for the namespace. So you can directly work on the application. So they give more importance on deploying the application. But in the OpenShift, so whenever you want to deploy some application, you have to create a project, and through the project we have to deploy the application, because yesterday we have seen the reason for that. So one reason is isolation, other reason is role-based access control will be giving for the user based on the so we'll see that the role-based, we'll see that in the section about the role-based access control, where we'll be giving the role-based access to the user depending on the project. So in this project, so for example, I have a pod, so a sample application, and this application required these details. For example, this application need to communicate to another application, so or another server which is located in different place. So I need to provision this information. So IP address, gateway, and domain. This details. This is an example. And this details which is required by this application are runtime information. So I cannot hard code this information into the application itself. So this is a runtime information, because IP address and these things are not a constant information. So that changes with the different environments. So where my application is running, so what is the IP address of that the application which it wants to communicate, what is the server name, and like this. This is just an example. I need to provide these details to the application. So these details, what I will do is I will create this things as a config map. So I will create this IP address, gateway, and all these things. I will create a configuration map. So this is a key value pairs. So the IP address is a key, and the value is the actual IP address. So this is the value. So this is again the gateway is the key. So this is called key values, or you can say literal values. So you can literally we are creating these values. You can create n numbers of values like that. You will create the config map, and later on what you will do is this config map you will inject into the application. So the corresponding value gets over here. So once the application sees this, it will use that to communicate to the other application. So maybe the application will be running in the same project, maybe in the different project or a different server. So maybe it is actual physical server itself. So it depends on how the application is the external application is configured. So based on that, it's going to communicate to that application. So we are provisioning this information in the config map. So whatever the information you are creating, so this information will be in the plain text format. So anybody who goes and views this config map, they can see this information in a plain text format. So this is this data is the secure data. You cannot do this in this way. So you cannot use the config map for the secure data. So you have to go for something called secrets. So secret, we want often we'll deal with the sensitive information. So in that case, we will go for something called secret. So there is an example for that. So one database application often requires credential to perform the database query. So this database credentials need to be stored as a secret. So the Kubernetes and the OpenShift use a secret to hold sensitive information such as passwords, sensitive configuration files, credential to the external resources such as SSH keys and auth tokens like that. And the main idea behind the secret is, so when you create the secret will be completely encoded. So, and also you can do something like for the secret you can do role-based access control. So normally normal persons cannot access the secret. Only the person who is creating the secret, he can access that secret. You can create something like role-based access control for the secret, so that they can only see that secret information. And normally the data which you are creating inside the secret will be in the plain. It will not be in the plain text format. It will be completely encoded using the base64 encoding method. It's not stored as a plain text here in the secret. So how this secret injection is happening. So before that, we'll see about the types of secret. There are 3 different types of secret. The first type is Docker Registry Secret. So Docker Registry Secret mostly used for accessing the private registry. So normally we have seen about 2 types of registry, public and private registries. Public registries, you can publicly publish an image. From that we can able to take the image and we can use it. So that's what we are doing so far. We are using the public image and deploying the application. And there are some private images, like I have my own private registry, or some organization they may have their own private registries. And this registries, if you want to access it, you have to create some kind of a secret, and you have to access that you have to give some kind of a permissions to the users who will access that private registries. So for that, you will be creating a Docker registry secret, and we'll not see any example here, so we're not going to see any use case. This is covered separately in DO280. So there is a development paper, OpenShift Development 2. So there it will be covered in detail as to how to use this secret to create the permission to access the private registry. That is a different concept, but this is one type of registry. So this is used for image management, registry image management, or you can say registry management or private registry management. For that it is primarily used. And there is other type of secret called Tls Secret. So Tls Secret is mainly the transport layer security. So where we will have the certificate and key, private key, to create that whatever that TLS credential informations are there. So we'll be creating that as a secret entity. So that's what a TLS secret is. So we'll see a use case in chapter number 5. So when we are securely deploying the application, there we'll see a use case of how to use this TLS secret. It's used for encrypting the TLS certificate and the private key. And the last one is, this is what we are going to use most often. This is a generic secret, so normal type of secret. So we have 2 kinds. So we can inject the secret in 2 ways. One, you can inject the secret as a file. If you have any file, any sensitive file or any configuration file, I want to bring that file into the OpenShift. So I will not directly bring that file. I'll bring that sensitive file as a secret. So the generic secret gives me that option to bring that file as a secret into the OpenShift. So this is actually a Kubernetes. You can do that in the same as a Kubernetes. You can bring this file as a secret in the Kubernetes also. And other option, so we'll go for something like a literal value. So we have seen like the literal values. In more often case, we have to use the literal values. So like the username and the name of the user, the password, the name of that password, there is the key, so key name and the key value. So we have to often use this literal values. So there are other options to use. In this chapter we'll see how to use the literal value using a file use case. We'll see in chapter number 3. So how to we'll bring a file we'll encrypt a file, or we'll create a file as a secret. So we'll see that with a use case in chapter number 3. And we'll see about this TLS secret in chapter number 5. So how to use the TLS secret, how to create the TLS secret, and how to use it for an application within a use case. We'll see over there. So in this chapter, we'll concentrate on this one. So generic secret, how to create this a literal value, how to consume this secret. So we'll be concentrating on this one. And this Docker image, Docker registry secret, so we'll not cover in this curriculum. So Docker registry secret is separately covered in DO288, which is development paper. So OpenShift development, there they will be covering about this Docker Registry secret, because there is a use case for that. And here we don't have exact use case to use this one, so we will not be covering this one. So this this generic type and TLS type, will see that within a use case in different chapters. Next we'll go to how you expose the secret. So methods of exposing the secret to the application. The first method is using getting the secret as an environmental variable. So environmental variable, like the application, which is the application container which is running, it's almost a virtual file system, or you can a virtual OS. So inside the OS, you can bring in some data as an environmental variable. So normally, if you look into any OS, when you type env, and when you type env and see that, you will see the environmental variables. So the same, like you can bring the data as an environmental variable to the application. So this is one method of exposing the secret. So for that, we will be using a command called ocset-env to set that environmental variables to the application. And so sometimes we'll be using the prefix option. So we'll see that how it is useful to use the prefix option. We'll see the use case. So this is a sample command where you are setting the environmental variable to a deployment file from a secret with some prefix. So this is one method of exposing the secret as environmental variable. And the next method of exposing the secret is using the files. So mounting the secret information as a file system into the container. So container has a file system. It has its own file systems. So we have seen. So you can mount your secret information or secret file or secret entities into the container file system as a volume. So this is another method. So we'll see this use case in chapter number 5. So how to mount secret information as a file system into the container. So it is this is what the second method. So second method we'll see. The first method we'll see in this now in this section. The second method we'll see in the chapter number 5. So how to use with a use case. So once you understand any use case, so you will be you can better grasp that concept. So whenever you're learning any concept, so you have to go for understand that concept through a use case, so that you can remember this concept well, or you can grab that concept well with a use case. When you understand anything, you can easily like you can refresh back and you can understand concept in a better way. So this second option is a secret can be mounted to a directory within the pod, and file is created for each key in the secret using the name of the secret, and the content of the file is decoded value of the secret. So this is a command to set the secret as a volume into that container file system. So there is a mount path. So this path is inside that container or inside the pod. You can specify the secret name. So here you can say the type is secret. You are going to add this one to the that application. So anything you are going to do that, you will always do that in the deployment file. So this is the last one is about the features of secret. The features I'll cover it after practically implementing the secret. I'll come back and cover this concept, the features of secret. Now I'll just hold up this concept now, so that because some points I'm going to practically implement it. So once I practically implement it, then you will understand that points in a better way. Then I'll come and discuss this features of secret. Okay. So if I now discuss it, maybe these terms will not be sound familiar to you. Once you see that things in a practically implemented way, then you can able to correlate this concept with that implementation. So I'll come back and discuss this after doing that implementation practically. So we'll build a scenario to understand it, how we can use the secret. And so configuration map. So configuration map, we are not seeing any use case, but we'll see once you understand how to use the secret. The configuration map is easy. So the same way how you are using the secret, so the same way you are going to use the configuration map. You're going to create this configuration map, and you're going to inject it, because in configuration map you don't have any types. So configuration is a single one. The other one, like the secrets, we have a type, but in the configuration map we don't have any types. Only we have a configuration map. the way you are going to create the configuration map, the way you are going to utilize or inject the configuration map is similar to the way you are going to utilize the secret. Since our chapter is about just managing sensitive information with secrets, so we'll give more importance to the secrets. So, but I'll show you how to create the config map and how to use it. It's similar to the way you use the secret. But we will not use any use case for the config map. So you can, if you're doing further studies, you can understand the config map, how to use it. So since our focus on this section is about using that for the secrets, using the secrets, how to deploy the application securely. So that is our main focus. So we'll concentrate more on secret. But anyhow, will see how to use the config map, how to create and use the config map. I'll say that later on. You can explore more on yourself about how to use the config map. So we'll go to the, we'll build a scenario as usual. So what I'm going to do is I'm going to create a so let me consider this as a project. So I'm just abstracting these things, like I'm creating a project. So we'll have a cluster inside the cluster. We'll always create a project. Just I'm directly creating a project. So let me say this project is my demo 3. This is the project name. Here I'm going to bring in an application, create an application. And so this application, which we are going to specifically use, will be a credential based application. So credential based in a sense, the application won't run without providing the credentials. That's what we call as a credential based application, or the application which requires a specific information to run. So without that information, the application won't come up or won't run. So we are choosing that kind of an application because that is where we can exercise the full functionality of secret. That is where we can use the secret. So normal application, some application doesn't require that. So we are not going for that. So we are going to concentrate on application which is a credential based, which requires that credential details to run. Without that, it is not going to run. So I'm choosing that kind of an application. Here I'm going for application. So mostly the database kind of application will be a better example for that. So here I'm going to deploy an application. So let me say this is I'm going to use MySQL database. MySQL database. Here, let me go and go to my lab. Login as student user. Okay. So as I'm going to build this scenario, we'll build the blocks one by one. So how to as I'm going to proceed on with the scenario. So let me open the terminal. Always you have to see whether you are into the cluster. So let me do OC home and check whether I'm into the cluster. So this shows my username. So that means I'm into the cluster. So now let me create a project. So OC new project. So I'm going to say this project is my demo 3. I'm creating a new project. Okay. So here I need to deploy an application. The specific thing which is required to deploy an application. So here I'm going to use the OC new app command. So just a reminder. So yesterday we have seen 2 ways to deploy application. One method is declarative architecture, where you can have a file. From the file you can deploy the deployments, whatever things you can. Through the file you can deploy the application. That is another one method. Other method is about using the imperative commands. So I'm going to use that. I'm going to follow that imperative architecture. So since we are starting with the Openshift now, later on we'll see around like chapter number 5, we'll be using the declarative architecture to create the application. Now I'm going to concentrate on imperative architecture. So in the imperative architecture, I'm going to use the command line to deploy the application. So I'm going to use OC new app command. OC new app -, name. I'm going to say this is MySQL DB. I'm going to use Docker image. So like so previously I was using QA registry. It's not that always you have to use QA registry. So you can use other registries also when you can get the image. If the image is like a public image, you can get it for the image from anywhere. So it's not that you always used to use the QA registry, but there was a question in the morning that so always like it seems like we have to get the image from QA registry. You can get it from other registry also. So for that, just to make it clear, I'm going to get this image from some other different registries. So for example, so here they have used in the book some different registries. They have used here redat.access.redat.com. So this is one registry. So this is a Red Hat registry. In this registry, they have made this image as a public image. So you can get this image from here also. And also you can get it from the QA registry. So QA registry also same image is available. But when you're using the QA registry, the path may be different. So I'm going to use this one. So you can get this one whenever you have any image. So it's always a good idea to see that the image is available using the Scopio tool. So I'll open another separate tab. So you can use a Scopio tool to check the availability of the image for our access. You can use inspect command and Docker. So this time I'm not using the QA registry. I'm using another different registry to get that image. So here I'm going to use redat.access.redat.com. So this is one of the registries. So inside that I have a repository, a Red Hat library. So inside that I'm having this image. So I'm just checking that so that I don't have access to it. So if you see the details of that image, that means you have access to that image. That means you can use that image. So you can see this is, I'm having access to this image. You can see the image details. So what is the purpose of this image? This is a MySQL multi-user database server. So this container image provides a containerized packaging of MySQL daemon and client application. So this is the image, and you can see the versions. So what are the versions tags available? So if I'm using this particular version, this is 5.7.-47. So I'm using that particular version. So you can see the registry. So I'm going to use this image from here. Okay. And now let me go and deploy the application. OC new app. So hyphen name. So I'm going to say MySQL DB. Can give any name. So I'm going to say Docker image. So here I'm going to use this image redat.access. From here I'm getting that image. You can also get it from the QA.io, so that's no issues. It's the same image, so say same containerized application. And here I will keep one watch window. I want to see something like I want to see this command when it's executing. I want to see that command execution changes in a real-time way. So when I'm executing that, I want to see that command changes in a real-time way. For that, what we can use is in the Linux there is something called watch command. So you can use this watch command. This is a Linux command. When you attach watch to any command in the Linux, so what happens is that command will be getting executed repeatedly. So like defaultly it will be executed for every 2 seconds. It will be getting executed repeatedly. So that this is called a watch window. So I will attach this watch command. So I will do watch. Now I'm going to say OC get pods. So what happens? This command, the OC get pods command, will get updated every 2 seconds. So it will be keep on executing this command in the terminal. I will not able to use this terminal, so I will call this as just as simply a watch window. So I want to see the things happening in an interactive way, so in a real-time way. So I will keep a watch window to observe what is happening in a real-time way. So that instead of every time executing OC get pods again and again. So I want to watch something happening in a real-time way. So I'm going to use this watch window. I'll keep this window intact so that I'm not going to disturb this window. So this window is going to execute this command again. So once I execute the command over here, you will see the changes of this one over here. So here I'm going to deploy this application now. So I have given the name, I have specified the image, and I'm going to deploy the application. So once I deploy the application, now I'll come back to the watch window. Now you can see it has started creating the container, and I have to wait and see what happens to that container. Actually, it is not going to run. It will go into the error state. So we'll see why it is getting the error state. We'll rectify that issue, and we'll see that how to use that for the use case. Now you can see the application has went to the error state called crash loopback of this is an error. So why it has gotten this error? So you can check the logs. So this, you can check the logs of this application. This will provide you a clue why that application has gone into the error state. So I just use OC logs, and I specify the name of that pod. So this will give me the log information, that is log generated by that pod. You can see the log is showing you must either specify the following environmental variables. So it's saying that without this environmental variable, this application will not come up. So I didn't specify this environmental variable. That's the reason why the application was not run. So I didn't provide the username, password, database. These details I didn't provide, or at least I should provide the MySQL root password. At least this environmental variable is required. At the minimum, I required this one to deploy the application. These are the optional values. So if I don't specify this, it's not going to get affected. But if you want, you can specify these values also. So in a detailed way, if you want to do that, you can specify these values also as an optional values. But mandatory values are this one. So at least I should have at least at a minimum level, I have to specify these three values, or at least I should specify the root password at the minimum, because this is I told this is a credential based application. Without these values, this application will not come up. And you can see that the image itself. So when you have described that image, there you can see the usage of that image. There itself they have mentioned that you have to use this environmental variables. You can see the usage section. This is in the Docker, but we are using it inside the Kubernetes. That's fine, but the usage remains the same. You can see they are providing the environmental variable using this -e option. So you have to provide this environmental variable to bring that application. Also, you can mention the port like that. These are optional values. So without this, the application will not come up. The usage itself, they are mentioning it. So here we are observing that through the logs. So the log is showing me that without this, this application will not come up. That's why the application is in the error state. So it is in the cache loopback of error state. So now what I will do is I will delete this application. I'm going to delete this application, and then I will recreate that application with the environmental variables. Then you are going to see that application is going to run. So here when you create the application, so when I want to delete it, I want to delete all these three resources together. So I have created the command. When I execute this command, three resources are created. One is image stream, another is deployment, and the service. So when you want to delete the application, technically if you delete the deployment, actually the application will be deleted. The pod will be removed. So if you just delete the deployment, so to delete in a clean way, so I have to delete all these three things, all these three resources which has created for this application, so that you don't have any residue in the application deployment. So otherwise this service will keep on be there in this project, and the image stream will be there. So I want to delete everything together. So I'm going to use this option to delete. So I'm going to use OC delete all -l. We say app is equal to. So I have to use the name. Yeah, stands for label, and app stands for the application name. So here the name of that application I've given here, because every resource is have the same name. You can see the name of the resource is having the same name, which is MySQLDB, which are given as the name of the application. You can see here this is taken as the name for that resource. So I have to mention this name commonly, so that it will delete all the resources together. So here I'll mention this name, and I will delete it. So now you can see all the things are deleted. You can see service, deployment, image stream. Once you delete the deployment, you can see that the application is now terminating. So it is after sometimes you'll see that it will be removed. I can see it. I don't have anything in this project now. It is removed. And now I'm going to deploy this application. So now how I'm going to deploy this? I'm going to specify the environmental variables when during the deployment itself. I'm going to say I'm going to use this MySQL_user and MySQL_password. Then I'm going to say MySQL_ database. So minimum it is required that information. So I'm going to provide this information, and then I'm going to bring this application. So you can observe that over here. So in the logs, you can see that this is minimum required. So username, password, and database. I need to provide this information, and then I'm going to bring this application. The same command, I will go to this same command. Here I'm going to specify the environmental variables. So here I'm going to specify, or I can just take it as a new command. So okay, just I'm going to use OC new app. I can name. I'm going to say MySQL DB. I will specify this environmental variables. So first I would specify the MySQL underscore user. So any name you can provide. I'm just providing the user as name as a Rocky. So I'm going to say -e MySQL underscore password. The password I have to provide as Red Hat. -e. Then I have to provide MySQL underscore database. So database, I'm going to say the database is my underscore DB. Any name you can give. So I'm just using my underscore DB. This is the database name. So this is a minimum requirement. So MySQL underscore password. The format should be same. Like it should be MySQL everything in caps underscore password. So the you can give any value on the right side, but the key should be same. So MySQL password, user, and everything. Then finally I have to mention the Docker image. So I'm going to mention this registry.redhat.com. So I'm mentioning this image, and I'm going to bring this application now. So once I bring this application now you will see that the application is going to come up and is going to run immediately without any issues. Now you can see the application is running. So previously it was not running, it was in the crash back off state. So reason was I didn't provide the environmental variables to that application. Now if you check the logs, so this MySQL database will be ready for connection. So you can check the logs, so it will be working fine. So you can do OC logs. If you check the logs, now you can see that it is fine. So it is over the port 3306. You can see now it is creating the user MySQL and creating the database. So granting privilege to the user Rocky for the database MySQL. So you can see the logs to this. You can see that everything is okay now with the application. So you can see the MySQL is started successfully. So everything is fine with that application. So the reason why it was not running before was it was not having the credential information. But with this kind of deployment, so I used this deployment method. With this deployment, I am unknowingly introducing a vulnerability. So what vulnerability am I unknowingly introducing here is the credential information which I am specifying over here is stored as a plain text credential, the plain text information into the application files or application source files. So here the source files are like deployment file. So when you do OC describe deployment, so the deployment is MySQL DB. So when you see this deployment file, here you can see this environmental variable which you have provisioned. So you can see that information in a plain text format. What is the value? So what is the key and what is the value? So this is not a preferred solution always. Like so to provision the credential information, so to see the credential information in a plain text format. So anybody who is inside this project, they can see this information in a plain text format. So what is the details, how you can access the database. Maybe this database may be a sensitive database, or it may be used for some credential sensitive applications. So in that case, this is not a preferred one. So the application details are there inside this location itself. And other way, so when you want to save this file, for example, you can view this manifest file through this command OC get deployment, and the deployment name is MySQL DB. So you can view this file using this option. You can use this either you can use the YAML option or you can use the JSON option. You can see the deployment file. So when you see the deployment file, here you can see the information. So you can see the environmental information. So here you can see the name, you can see the value. So values you can see as a plain text format. So you can see that directly what is the value is. So somebody can redirect to this to my terminal. This is there in the API server. So I can redirect this standard result to my my terminal itself. I can just save a file MySQL dot YAML. I'm just redirecting my request to a file, or you can say JSON. This is JSON. So I'm redirecting this result to a local file. So if you view this file, mysql.json, so there you can see the information. So you can pass on this information to anybody, so that they can able to recreate this one, or they can able to access the database using this information. So you can see that if you scroll down, you can see that information. So MySQL database, the value, and all these things. And this is a vulnerability. So unknowingly we are introducing a vulnerability. So by placing the information directly into that application. So this is not preferred method in the enterprise deployment. So what we have to do is, now we have to take advantage of the secret, and what we have to do is we have to isolate the data from the application, and at the same time the application should also work. So data should be isolated so that the information is not available directly for anybody to see that information. And at the same time, if you isolate the data, what happens? The application will not work. So we have seen that without that credential information, application is not working. But at the same time, the application should work. So how we are going to achieve that? So we are going to isolate the data, create that secret, and we have to inject that secret into the application. So that application is also going to run at the same time. So we have isolated the data also. Okay. So that's what we are going to achieve over here. So we are going to eliminate this vulnerability. So I just come out of this file. So I need to eliminate this vulnerability. So what I'm going to do is, here, what are the information which is there inside this application? I'm going to isolate this information, take this information away from this application, and I'm going to create this as a secret. Okay, so I'm going to create this information as a secret. And here inside the application, I am going to just inject this. I am going to have only the reference. So the reference, I will be referring to the secret. So I'll be creating a secret. I'll call this secret, you can give any name for the secret. I'll call this secret as DB Secret. Okay. So DB Secret. So only I have a reference to that secret. So inside this application, and I will not have the data into the application. So what I'm going to do is, I'm going to create a secret now. This secret, which I'm going to create now, so I'm going to create it in a generic way. So I'm not going to create as directly as MySQL user. So I'm going to create a secret. I'm going to call this secret as DB Secret. Okay. So here I'm going to provide the user name. The user, I'm going to provide the user as Rocky. Then I'm going to say the password as Red Hat, and I'm going to provide the database. The database, I'm going to say this is my _db. Okay. So when I do this, the username, and when I create this secret, so you might wonder why I'm creating this in this way. You can see I can directly create this as a secret as MySQL user. Then I can mention the Rocky and this thing, but I'm creating this in a generic way so that I can reuse this secret for some other different application. So that's the idea behind it. But when the application want to consume this secret which I have created over here, that has to consume in this format. It will not accept this format, like user directly, just directly the user password. So how this application is going to consume that? There we are going to use something called prefix option. So here I'll be using a prefix option. Here I'm going to use -- prefix. The prefix option, I'll be mentioning this as a MySQL _. So what happens is, when this secret which I have created here, when this application is going to consume this secret, so this is going to consume inside this, the value will be going as when it's going to consume this secret, this value will be going as MySQL _user. even though I have mentioned this in a small case, this will convert that to the uppercase, and it will take that value as MySQL underscore when you mention the prefix. So here the MySQL underscore plus user, that will be MySQL underscore user, and that value will be taken into the application. Similarly, MySQL underscore, this will be capitalized as password, then it will be taken as MySQL underscore password, whatever the value over here, that will be taken into the application. So this is the idea behind using the prefix. So with the help of the prefix, I can reuse the secret for different applications. So later on we'll see about that, how you can reuse the secret for other application with the prefix notation. So this is the idea behind the prefix notation. I can directly do that also. So there is no constraint over that. You can directly create a secret like this. If you're creating a secret for one single application, that will be fine. So I'm just exploring one option available so that you can reuse the secret for some other different application by creating that secret generically. And at the time of consumption, I'm going to use the prefix notation to get that information as a preferred notation inside or as an accepted notation for that application. Okay, so that's what we're going to do. So here now let me delete this application now. So the application is now running. So I'm going to deploy it in the first way. So now I'll delete this application. I'll delete everything. So here I'll deploy the application. So now this is terminating. Now I'm going to deploy this application again. So this time I'm not going to mention the environmental variable. So I'll follow this method. So if I don't mention the environmental variable, ultimately the application will go into the error state because it doesn't have the required information to run. Later on, what I'll do, I'll inject this information. So whatever the application is required, what are the information the application required to run, I'll inject that information to the application. Once I inject it, you will see that application is going to take that information. If that information is acceptable, then the application will run. So if that information is not acceptable, then it is going to still it will continue to be in the error state. So we'll see that how it's going to work. So if I'll deploy the application, and now you will see the application will go into the previous error state, the crash flyback of error. I'm going to rectify this issue. So how to rectify this issue is first I have to create a secret. So now I'll create a secret. So here I'm going to create OC secret. So here you can see, sorry, I have to use create OC create secret. So here you can see 3 types of secrets are available. So you can create a Docker registry secret, and you can create a generic secret, you can create a TLS. So here we'll use the generic secret, and generic secret also you can create in 2 ways. One is you can create a file as a secret, and the other one is you can create a literal value. In this section we'll cover only the literal value. File we'll see in the chapter number 3, so with the use case, and also this TLS secret we'll see in the chapter number 5, where we are going to use with it for a specific application deployment. And here we're going to create a generic secret. So I need to give a name for this secret. I'm going to call this as DB secret, and I need to get the literal values from literal. The first literal value is the username. So user, I'm going to say user is Rocky, the first literal value. Then from literal, the second literal value, I'm going to say the password. The password I'm going to say Red Hat, and from literal, the third value will be database. The database I'm going to say my underscore DB. So here I'm creating this secret. Okay, so I'm going to create the secret, and later on I'm going to consume this secret to the or inject this secret into the application. You can call this a secret injection. So I'm going to inject this secret into the application. So I'm going to create this secret. So see that the key values are correct, so don't make any typos here. If you make any typos, this value will not be accepted. So it should be as, even if it's small case, it's fine, but the spelling should be correct. So it should be database, and it should be a password, and should be user. So I'm creating this secret now. Now you can view the secret. So OC get secret. Name of the secret is DB secret. You can view the secret in the YAML format or in the JSON format. I will view that secret in the YAML format. You can see that you can see the data. Here you can see the information which I have given. So here I have given the database password and the username. You can see that information, but you cannot see what is the value you have given. So in the command line, you are given this value. Even you can avoid giving this value in the command line also. Like you can, there is some option in the Linux to hide the data. So when whatever the data you are typing, so there is an option in the Linux to hide that data. So you can say they use something called password method. So you can hide the data. So even you cannot see what you are typing in the what you are typing in the command line. You can use that method to hide the data even in the command line. So then you will not know what data you have provided even in the command line, or you cannot go and find it in the secret. So here you can see the values are completely encrypted. So you cannot see the value. So it's completely encrypted. You can see only the key values. So whatever the key you have provided, this is for our reference. But what is the value you have given, you cannot see. So unless you know what you have given. So somebody who is seeing from other end, so they see the secret, they will not see what the value of that secret. It's completely encrypted. And now the second job, so still the application is not going to run because it is still in the error state. So I have to do the second step. I have to inject this secret. Then only the application is going to run. I have to inject this secret through this prefix into the application. Then only the application is going to run. Okay. So now let me do that. So to inject that secret, so I'm going to use the command oc set env. I'm going to inject that as environmental variable. There are two options to inject that. One is as a file system. The file system injection will see our file system mounting a secret as a file system into the application. We'll see that in this chapter number 5 with a use case. So here I'm going to inject that as an environmental variable. So secret can be injected in two different ways. One is as an environmental variable. Now, and the second one is using it as a file system. So here the requirement is to inject the secret as an environmental variable. So yeah, the -e option, the same thing, we are going to inject that as externally as an environmental variable. So here I'm going to set env. So I'm going to set it from secret. The name of the secret is db secret. Okay. So I'm going to set it from the db secret. Then I'm going to use this very important prefix. So prefix should be mysql underscore. So this is the prefix. So whatever the values you are injecting, it will be taking as mysql underscore. Then it will be taking as a user. So user will be capitalized. So it will take in this format, mysql underscore user to enter the application. So I'm going to use the prefix. Then I need to mention the deployment file name. So I'm going to say deployment slash the deployment name, which is mysql db. That's the deployment name. So deployment is created when you create the application. So this is the deployment name. You can see this deployment name is mysql underscore db. So I'm mentioning the deployment name here, and I'm going to set this value. So once I set this value, you are going to see immediately the application will create the container again. Then it will accept that input, and it will see that input is whether it is in the acceptable range. So once the input is acceptable, then it's going to deploy the application. Then it will terminate this error state container. It will remove this one, and you will see that container is going to run. So I'm going to set this. Now you can see this is updated. Now I'll go here. You can see now it started immediately creating the container. Whenever you do any modification in the deployment file, so it will immediately trigger the new configuration. So even if it is 100 application or 1000 application, it will immediately re-trigger the application. You can see now it is terminating the error state container. Now you can see now this pod is running because now the values are acceptable. Now it is running. So what we have achieved through this kind of deployment is that, so we are able to eliminate that vulnerability. So what vulnerability we were having? So previously when I was seeing that file, so when I was seeing that deployment, so when you looked into the deployment, you are able to see that what are the values you have given. So you can see that value as a plain text format. You can see the database. You can directly see the value because I have given that value during the deployment itself. Now through this way of deploying application, a secured way of deploying application, I have eliminated this vulnerability. Now if you look into the file, or if you do that, if you do oc get deployment, or you can see that previously when I was describing that deployment, when I was describing the deployment, you can see the value in a plain text format. You can see that So now if I do the same thing, if I do OC describe deployment, if I do the describe deployment, you can see now the same thing. You can see the value is set to some key. You cannot see what is the value, but you can see this is set to the key password in the secret. But what is the password? You cannot see over here. That is there in the secret. Even if you go and look into the secret, you cannot find what is the password because that is encrypted. So you can see the user. You cannot see the user information. You can see where this value is coming from. So you can see the reference, because I need to know where this value is coming from. For that, it's just showing that set to the key. The key is the key which is there in the secret. This is coming from that secret. You can see that information. But what is that value? You cannot see that. Even if you look into the file, even if I just do OC get deployment. So the deployment name will be MySQL DB. So I just want to see that file in the JSON format, or you can see in the YAML format also. If I see that file, here you can see the environmental variable for the container. You can see the environmental variable. So you can see the key, which is MySQL password. So you can see the value is coming from the secret key reference. The key is password, the name of the secret. But what is the actual value? It's not there over in this file. But previously, if you look at that file, so which I have read mysql.json, if you look into the file previously which I have done, so you can see the environmental variable, which was, this is a previous deployment case where you can see the value directly. So this is the value you can see, but now you are not seeing the value directly, as we have did the deployment through the secret. So whether this is working fine or not, so we'll check that. We can check that also. So this pod which is running, so whether it's already running, so you can see whether it's what are the values you have provided that is there as an input inside this application or not. We can find that also. I can do a OC RSH, and I can go to this application MySQL DB, and I can just do MySQL user. So I can say I have created the user as Rocky, and I've used the password as Red Hat. I can say I can log into the MySQL server. I can do a query, so I can just see the database. So now I can see the database is available inside the application. So everything I have created that as a secret information. So I have inputted that information. I have given that information as input to that application, or you can say injection, or you can inject it into the application, and you can see that values are there. So these values, whatever I have given, so this is available inside the secret. So this is now working fine. Okay. And this secret now, which I have created, the reason you can see, one question may be in your mind: why I have created this separately instead of creating? Why can't I create this as directly the secret and inject to this application? The purpose of creating this secret as a separate entity, the reason for that is to reuse the secret. The same secret can be injected for a similar kind of an application. For example, in the same project, I'm going to deploy another application. Say this is also a database kind of an application. So this is, let me say this is as a PostgreSQL. Okay, so PostgreSQL database. So I'm going to deploy this application. So for this application, okay, when I deploy this one, so this is also credential based. Since it's a database, it requires the credentials to initially start the database server. So it requires the credential information. Without that, it's not going to run. So we can see that information. Like I can just use OC new app. So I'm going to say hyphen name. Let me say Postgres, or I can say PSQL or PostgreSQL DB. And here I'm going to say the Docker image. So I'm going to use an image. I think previously we've done that in we used an image in chapter number 2 for troubleshooting, I hope. I'll use this image. I'll be using this image here. Okay. So I'm going to bring in this application. So the environmental variable is missing. The application is not going to run. But anyhow, I'll deploy this application here, and I'll go check the status of the application. Now it's trying to create the container. Once the container is created, this will look for the environmental information, and the environmental information is not available. Then it will go into the error state. So you can see now it has gone into the error state. So this is a crash loop backup error, and you want to find out the reason why it has gone to the error state. You would check the logs of this application. You do just OC logs, check the logs of this application. There you see the information. The information is that for general container run, you must either specify the following environmental variable. So I didn't specify this variable. That's the reason the application was not running. I need to provide that information. So previous case I was using MySQL underscore. Now I have to use PostgreSQL underscore database like that. So here I already got a secret. So I need to find a way to inject the secret. So here the only difference when you want to inject the secret into the application is that you have to use the prefix will be different. Here you have to use PostgreSQL underscore user. Copy this. Then I have to use here password. Then I have to use here last one, database. So this will be my values, and this I'm going to inject into the application. So from here to here I need to inject into the application. Okay. So now I will use the same secret. I will inject into the application, but here when I'm going to inject into the application, I'll use the prefix. Prefix will be different here. Prefix. So here the prefix will be PostgreSQL underscore. This will be the prefix. So this prefix will be injecting into the application. So here the prefix is different. So same secret, I'm able to reuse it for this application. So the reference will be same. So here the reference is going to be same for this one. The reference will be same for this inside. So here you can see how I'm using one secret can be shared to the two different applications with the help of the prefix. So this is a special case, like you can use it for when you space this kind of scenario, you can do it. Otherwise you can directly use it. You can create, instead of creating this secret, you can create the values just this secret and they can get into the application. That is also possible. So here just to demonstrate, to show you an option whether you can use a one secret to be shared between two different applications. One same common secret can be used. So just to show you that option, I'm just using this here. So you can, if you want, if you have just only one secret, so there is no use case for you, like you are not going to use this reuse secret for other application, then you can directly inject that into the application without that prefix notation. Directly you can inject it. So if you are not reusing it, only when you are going to reuse that secret, in that case you can go for this kind of an option. So there's an option just to show you that option, and just I'm going for that method. Now I'm going to re-inject this. So now if you do OC describe deployment, name of the deployment is PSQL DB. So if you describe the deployment, here I'm going to grep for the environmental variable. So you do in environment. So if you grep the environmental, I don't have any environmental variable now. So I'm going to inject this environmental variable. So during the injection, so OC set env, this is a command. So I'm going to inject it from the secret which is already created, either is db secret. db secret. Then I'm going to set the prefix hyphen prefix. So what prefix I have to set it? The prefix should be this one, so which is Postgres SQL underscore. This should be the prefix. And I need to say the deployment name. The name of the deployment is this one, which is the deployment name. I'm going to inject this. So once I inject it, so you should see the application should go into the running state. So you should observe that once I execute this command, this will update that deployment. Once it's updated, so the configuration will be re-triggered. So once it's re-triggering, you're going to see that application is going to check that value. So if it's acceptable value, then it's going to run. So if it is not acceptable, you see that again it will go into the error state. Okay, so I'm going to get this. Now it is updated. Now you'll see that it immediately creating a container. So it's going to take that value from the secret. Once it's acceptable, then you'll see this is going to running state and the crash flow back will be terminated. So now you can see this is terminating. Now it has got into the running state. Now you can compare this value. Now you can check. Sorry. Here you can just give a grep. You can just use A3. A grep here. You can see the environmental variable, and also you can compare with that MySQL also. So this is also now coming from the secret DB. So the same MySQL DB. You can check that. So I'm using the same secret, the DB secret. The value is coming from the DB secret. But when it is consuming, it is using as a like Postgres SQL underscore password. But when the MySQL is consuming, it is using as a MySQL underscore password into that application. You can see that. So that's what our scenario is. So I'm using one secret. So sometimes you face some kind of situation like this. Maybe I will not say that always you are going to face this one. So like it's not general good idea to use one secret for different application, but this is an option. When you face this kind of a situation, so where some testing environments, you can use one secret instead of just creating secret for all the databases. In that cases, you can go for this option. So this will be helpful to share a secret within the different application. Okay, so using the prefix notation. So this is a scenario. So now we'll go and discuss about the features of the secret, so which I left over. So now we'll understand the features of the secret. The first feature is that secret data can be shared within a project namespace. So that's what we have seen. So one secret that is shared between different application within one project, which is here in our case it's MyDemo3. So this is one of the feature. Other feature, secret data is referenced independently of secret definition. So here I've defined a secret. Now through the prefix option, I can independently reference it. So MySQL also can use. At the same time, Postgres also is going to use this same data. So using the prefix notation, now both are independently referencing it through the prefix option. Okay, here you can see the environmental variable for the Postgres is also coming from the same secret. You can see the DB secret, as well as the MySQL. It's also coming from the same secret as well. And you can see both applications are running without any issues. Then secret data is injected into the pod when the Openshift creates a new pod. So you can expose the secret. So that we have seen. So we have exposed this as an environmental variable, and we'll see the mounting the file system in the later case. So we'll see that. So now you can see we have seen that we have exposed the secret as environmental variable. So this is exposed as environmental variable into the application. So we have seen the secret here. So we have seen one method. So there are other method also there that is using the file system. That is another feature of the secret. We are injecting the secret into the pod. We are able to we can do it as a post installation option. We are injecting to the application. And the next important point, if the value of secret changes during the pod execution, the secret data the pod does not update. So we have to manually go and update that secret information. So that as a security reason, manual update that automatically to not get updated. So we have to go and re-trigger that application. So that application is going to get that secret information is going to run. And last is the secret information is not cacheable. Cacheable in a sense, it will be there only during the lifetime of the pod. Once the lifetime of the pod is gone, whatever the secret you have created, that will be destroyed. So that is the other feature of the secret. So the information is not cacheable, so that somebody cannot get that value and able to fetch that value and able to access that particular entity or particular application. the secret data will be available only the pod lifetime. The pod is destroyed, the secret information will not be cacheable. You cannot find it anywhere else. So that will be gone. So that is the other last feature of the secret. So with that, we complete the session.
So actually, in this case, if you are deleting this MySQL database, will this secret will also be deleted, or else we have to delete both the MySQL and PostgreSQL database?
No, the secret will not be deleted. Secret will be there. Only the MySQL application will be deleted.
So it says that ephemeral, right? I mean, once you have deleted the pod, the secret will also be deleted, right?
No, a secret will not be deleted. Secret we have to delete it individually because secret is in the referenced by the multiple application. So secret will not be deleted as as you delete the application, secret will not be deleted. But if you delete the secret, application may be affected. So when you do the redeployment of that application is going to look for that secret. If the secret is not available, then application will fail. So it is going to look for the things, but both are independent. So you have to, if you are deleting the secret, application will not be deleted. If you delete the application, secret will not be deleted. Both are independent. So you have to manually delete the both things.
Okay.
Because the option is like I can create a one similar application with a different secret. That's the idea behind it. So I can create like one secret, like I can create a MySQL application. One MySQL, for example, in the same project, I have two different MySQL applications, and I'm going to use two different secrets for that. So that it independently works. So by deleting the application, the secrets will not, because that interlinking will not be there for the application. So you have to independently delete that.
Shall we modify the secrets value?
Yes. We will see that. Yeah. So to modify the secret, there is a procedure to do that. We'll see with the specific case in the chapter number 3. So this is the updating the secret information. So there is a command called OC extract secret. So this will extract the secret to some temporary information, to a temporary file. There you can extract that secret information. After extracting it, then you can, if you want to do any modification, you modify that information. Then you apply that modification using the set data command. Using this set data command, you can modify it. We'll see this one with a use case in chapter number 3, so that you will understand how, because there will be a requirement. We'll be creating a secret, and there will be a requirement to modify that secret, to set that secret. So we can do that over here. So this is the option. So you will extract, this is a procedure. You have to extract that secret to some file here into a local system. Then you modify that information, and then you can apply that information using the set data command. So we'll see then a use case in chapter number 3. So there are a lot of things which we are not covering in that secret. So we are not seeing this one. We'll see that this one in the chapter number 5, how to use this volume, how to apply the secret as a volume into the file system. And we'll see this one about secret modification, all these things in chapter number 3. And also one more thing, like the file system way of getting the secret. So here I use the literal values to get the secret. There are other method, like if I have a file, if I have a sensitive file, so I want to get this sensitive file. So maybe the file may be holding some usernames and passwords. So I want to get this file into the Openshift. So I have to create that as a secret entry. So that we'll see that also as a in the chapter 3 as a part of our use case.
Okay.
Okay. I think, yeah. So now we can start the guided lab on chapter number. On page number. There's a guided lab. So here, what you're going to do is, in this guided lab, you'll be creating a project. Project is called Authorization Secret. You'll be creating a project over here. So similar to the way I used the one secret for two different entities, here in the same way. So here you will create a project. So in this project, you are going to create a common secret. So you will create a common secret, and this secret which you are creating here will be shared by two entities. One it will be a database. So one will be a database. Another one will be a application. So there is going to be an application called a codes application. Application name is codes. So it is going to just provide you some when you reach this application, it will provide some famous codes. So this codes required a database at the back end. So it is going to use MySQL database, and this application will be able to connect to this MySQL database through the secret. So you will create a common secret. You will specify this secret information into this application as well as the same secret information into the MySQL database. So that this application is able to connect to this one through this secret. So this is what you are going to do in the lab. Okay. And one more thing you will see in the lab, the method, creating the secrets, you know how to create it using the OC create secret. The type will be generic, name, then literal values. Then you will create the application. Then the application will not be running without such secret. Then you will inject that secret as environmental variable. So after this is fine, then you will see the application will get in the running state. After that, one more thing they are going to do here. They will see here they are verifying this things. So whatever they have created. One more thing you are going to do is you are going to deploy that. So you are going to use the set volume command. So this I didn't do it. So here we're going to mount that secret inside this file system. So using the set volume command, and this is not required actually. The application is running. So just to use this option, as I told, we have two different options to expose the secret. So here they are using it. So set volume command to mount that secret, whatever the secret you have created. So you are mounting that secret as a file system inside the application. So that you can verify that secret by using this command. So you can verify the file. Inside the file you can find that secret information. So you're mounting this just to see the option. So how to use this, how this option is used over here. But there is no use case here. So even if you don't use it, the application still runs. But to see how to use, we're going to use this option. So I didn't cover this one. I'll cover this one with the specific use case in the chapter number 5. So they are used to the specific use case, but here we don't have any use case. This is just for simply the purpose of demonstration. They are using this command. Even if you don't use this command, it will be running. That's all. After that, you will create the codes application, and the codes application will fail. So you have to point out to the secret which you have created for the MySQL application, so that it is going to connect to the so that this codes application is able to connect to the MySQL DB through this same secret. Then you will see this application will be running. Then you'll do something like you will be exposing the application. Exposing we'll see, because this concept of exposing the application we have not covered that. We will cover this one in the networking chapter. So, but for the type of for the time's sake, you just have to use this command now. Maybe this command may not be familiar to you, the OC expose command, because we have not covered the networking chapter. So you can just, for the time's sake, you can use this command. This just, you can say that this command is used to expose the application so that you can access the application and test it whether the application is reachable or not. For that purpose, you are just exposing it. Then you will get a route. So all these concepts you will see later on. What is a route? What is a service? What is the meaning of expose? All these things we will see in the chapter number 5, so which is about networking. So these are all the networking concepts. For the time's sake, you can just expose it. Then you can do a curl and reach the application, so that the application is reachable. And you can reach the application and see the database connectivity and all. See that this is producing this output. This is what actually the codes means. Every time you do a curl, you will get a codes. You will get some famous quotes from the famous personalities. So you will see that codes over here. So once this is happening, that's fine. So we are doing an application deployment. So here I used a different option so that you can have an idea about how these secrets are used. So in the guided lab, you are going to use it for an application deployment. Okay. So that you have about idea about how to use a secret for a common way how can use the secret. So you can start doing that on page number 95 in the PDF. Here you can start. So here the outcome of this lab should be you should be able to manage secrets and use them to initialize the environmental variable. Use secrets for the MySQL database application. Assign secret an application that connects to a MySQL database. So we are going to do this. This is the outcome of this chapter. And you can run this lab setup command. So make sure you're running this lab setup because this will prepare the lab for you, your usage. So always run the lab setup command. Then you start proceeding with this. So there is a task. So always there is steps to see. So you can go through the steps. If you know how to do it, you can proceed on your own. Otherwise, you can go through the steps and you can do that step by step. Okay. So we'll start the next session. It's almost 11:07 like here. I will start by 11:35. We'll start the next session.